So today let's see this rotate an image matrix problem. So it's a medium problem. Let's quickly jump into the description. So you're given an n-to-n 2D matrix representing an image, and we are asked to rotate the image by 90 degrees clockwise. Okay, and they're saying that you should rotate the image in place, which means we should not use extra memory. You should use the same matrix. And given this input matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, you have to rotate this matrix in clockwise. Also, you should rotate the matrix in place. So how do you rotate this matrix? Let's say you have a pointer at 7, right? You have the reference point at 7. Let's pull this and rotate this matrix. So when you rotate it, you'll get 7 on the top, and 4 will come next to it, and then 1 will come next to it, right? And whatever it is next to 7 will come again at the top, and then beneath 7, and you will have 852, and then beneath 852 will have 963. So that is how this rotated matrix is got. So if you have trouble understanding this, maybe you can write all these numbers in a paper and then try rotating the paper, and you'll observe that 7 will come to the top, and 4 will come next to it, and then 1 will come next to it. In other words, you can have a reference point at 7 and try imagining that you're pulling to rotate it clockwise. So if you pull this up, right, 7 will, if you pull this up, 7 will come to the top, and 4 will come next to it, and 1 will come next to it, and whatever is beneath 8, right, since we're pulling 7 to the top, 8 will also come to the top, but then since 7 is at the top, 8 will be beneath it, right? So since we are rotating this in place, right, what the approach that we're going to employ is we're going to transpose the matrix. So what is transpose of a matrix? So transpose of a matrix is nothing but you transform the rows into columns and columns into rows. So 1, 2, 3 is a row here in the input matrix, so 1, 8 will become a column in the transpose matrix, right? And 2, 4, 5, 6 is a row, and then it will become a column. So 2, 5, 6, and 3, 7, 8, 9 is a row, and it will become a column in the transpose matrix. And now if you observe the transpose matrix and the output matrix, right, you see that 4, 5, 6, the middle column is same. And 1, 2, 3 is the first column in this intermediate matrix, the transpose matrix, and it is the last column, the expected matrix, which is the rotated matrix. And 7, 8, 9 is the last column in the transpose matrix, whereas it is the first column in the rotated matrix. So once you get the transpose matrix, what we have to do is we have to just swap the first and the last column. So basically we're going to employ the reverse approach here. We're just going to have a pointer pointing to this column, and then we're going to have another pointer pointing to this last column, and basically we're going to just swap these values. And if you observe, right, this input matrix and the transpose matrix, let's start I is equal to 0, and I will be less than the number of rows, which is 2, and let's say j is equal to 0 and j is less than 2, I mean 3, it is actually 3, sorry. So 0, 0, so initially I is 0 and j is 0, right? 0, 0 remains the same, and if you consider this as 0, 1, 0, 1 is 2, 0, 1 will come to 0, 1 will go to 1, 0, right? It has come to 1, 0. So if you see 0, 0, it remains as such 0, 0, and then 0, 1 has come to 1, 0, and then 0, 2 will go to 2, 0, right? So which means that the first iteration itself, we have transformed the first column, right? 1 has come to 1, and 2, which was here, has come to here, and 3, which was here, has come here, right? So in the next iteration, you should not start from j is equal to 0. You should actually start from j is equal to the row, whatever is I, because if you start j is equal to 0, then we will be potentially overriding it. So next iteration, you will actually start with 1 and 0, right? And 1 and 0 will be replaced with 0, 1. So 1 and 0 is now 1, 0 is what? 2. And now when you replace it with 0, 1, you're just making it the same matrix again. So we should not override the same matrix again. So we should actually start the second loop with j is equal to I. Okay. Let's transform the matrix and come back to the next step. Okay, so let's transform the matrix into a transpose. For simplicity, I'm going to have n rows equal to matrix dot length and n calls is equal to matrix of 0 dot length. So we are going to do a transpose. N rows equal to 0, row is less than number of rows, and row plus plus. Okay, and for n column is going to be row, because when you complete the first row at iteration, you would have already completed the first row column. Basically saying that when you complete the first row, you're ensuring that the first column elements are also in place. So you should start column is equal to row. Column is less than number of calls and call plus plus. So we are basically doing a swap mechanism. We are saying row and then we're saying call. Okay, I'm just going to copy this to just save time. Go to this. So row will become column and column will become row, and transpose matrix just saying to this, and this will become our temp. Okay, so now we've got the transpose matrix, right? So we are here. Now if you so the first we observe the transpose matrix and the output rotated matrix, we see that the first row has become the last column. So basically what has happened is 0 0 has become 0 2 and 0 1 and 1 0, this has become, so 1 0 is what, 2, and where is 1 0 is what, 2, right? 1 0 is 2, and where is 2 here in the rotated matrix? It is at 1 2. Okay, so basically if you observe this pattern, row is same because row is going to be the same, right? The column is only differing. So how do we get this column, right? 0 has become 2 and 0 has become 2. Let's take another example. Let's consider 3, the element 3. The element 3 is, or let's consider the element 9. Okay, the element 9 is at 2 comma 2. And where is that? Where is that at the rotated matrix? It is at 2 comma 0, right? So which means row is same, column is different. So when basically how do you get this is number of columns, which is 3 here, minus the current column, minus 1 will give us this value, because here current column is 2, number of columns is 3, so 3 minus 2 minus 1, it is going to be 0. And same thing applies here. The current column is 0, number of row columns is 3, so 3 minus 0 is 3 minus 1, which is 2, so the target column is 2. And if you see, in any reversal approach, you have a pointer pointing to this and you have a pointer pointing to the last one. Once you swap these to the middle element, will be already in place, right? And even in string comparison and string reversion example also, you see that the first and the last will be swapped, and by the time you reach the middle, they'll be already in place. So we are just going to iterate over columns, n columns by 2, because the middle column will already be in place. Already have the required values. So let's transform this transpose matrix into the expected rotated matrix. And rows and row plus plus, and for n column equal to 0 and call is less than n calls and call plus plus. So again, employ the swap approach. You're going to have a temporary variable and just going to say already copy this. So this is going to be matrix, and so we saw that matrix of row is going to be the same, whereas this is going to be n calls minus call minus 1. So let's put that value in the target. Row is going to be the same. This is going to be n calls minus call minus 1. This is going to be the temp value. So let's run this code, and as I said, by the time we have reached the middle, it will be already in place. So we need not do this. So get the transpose matrix and then transform the transpose matrix into the rotated matrix. N rows, this should be n rows. Okay, because we have got that. So it is accepted. Submit this. It takes so much of time. Okay, so if you see it, 18 minutes ago I submitted it, it was 0 ms, and now it is 1 ms. I have no idea. It was the same approach. So there is something wrong with the LeetCode time calculation algorithm, because the same approach, it's 18 minutes back it was saying 0 ms consistently. So yeah, that's it guys. So this is the answer. So basically when you rotate a matrix, you're just going to do a transpose of the matrix, and then you have to just transform the transpose matrix into a rotated matrix by just reversing first and the last columns. Thanks guys, I hope you liked this video. Bye.